deep pulse, mysterious hum. What if most of the universe is invisible? Not stars, not planets, but dark matter and dark energy. The unseen forces that shape everything. Together, they make up 95% of the cosmos, yet we know next to nothing about them. Only 5% of the universe is ordinary matter, the stuff that makes up you, me, and every star in the night sky. The rest is a mystery, and understanding it could reveal the fate of the entire universe. Part 1. The Hidden Cosmos. First, let's talk about dark matter. We can't see it. It doesn't shine or reflect light. But we know it's there because we can see how it affects things. We can see stars and galaxies. Visible matter just doesn't have enough gravity to hold itself together. If you've ever spun a plate on your finger, you know exactly what I mean. Without something holding it together, the pieces will fly apart. That's what happens when galaxies spin too fast. The stars whiz around the center of the galaxy so quickly that the normal gravitational pull of their visible matter should rip them apart. But they don't fly away. Something invisible is holding them together, adding extra gravity to the mix. We call this invisible stuff dark matter. It's like an enormous, elaborate spiderweb stretching throughout space. We can't see it directly, but we can watch its effects on the galaxies that move through it. When galaxies collide, they pass through each other without breaking apart. And that wouldn't be possible without dark matter. Because while regular matter might not hold galaxies together, dark matter does. And we know that because scientists can see galaxies spinning way too fast. They know that those galaxies are held together by some invisible force. And while they don't know exactly what that is, they do know that it's not dark energy. Dark energy is the opposite of dark matter. It tears things apart instead of bringing them together. It's the mysterious force that's pushing our universe apart. You know when you blow up a balloon, it gets bigger and bigger until pop? That's kind of like what's happening to our universe, except it's happening everywhere at once. Astronomers know that the universe is expanding, but it's expanding faster and faster. And that can only mean one thing. There's some kind of force speeding it up. And that force is dark energy. For now, astronomers can only guess at what dark energy might be. Some think it's a property of space itself. Maybe the more space there is, the more dark energy there is. Others believe it comes from a type of particle that hasn't been discovered yet. Either way, we know that it's behind the accelerating expansion of the universe. In other words, it's making the Big Bang Theory obsolete. Originally, scientists thought that gravity would slow down the expansion of the universe. If that were true, the universe would be getting bigger, but not faster and faster. Yet here we are, racing away from each other at speeds that are constantly increasing. So dark energy is everywhere in the universe, permeating all of space. It makes up nearly 70% of all existence. And yet, we have no idea what it truly is. The good news is that dark matter and dark energy aren't the same thing. It's just that they both make up 95% of the universe. So, studying them could tell us how the universe began, how it will end, and perhaps whether we're living inside a computer simulation. Part 2. Dark matter. We've already established that dark matter is the invisible stuff. That holds galaxies together, but where did it come from? To answer that question, we have to go back to the beginning of time. After the Big Bang, the universe was a hot, dense soup of particles that eventually formed the first atoms. But these first atoms were mostly hydrogen and helium. For millions of years, stars were mostly empty space. Sure, they had some matter floating around inside them, but not much. And that's not the whole story anyway, because if we look at a star and measure its mass, then measure how much light passes through it, we find that there's more mass than should be there. Basically, it's heavier than the sum of its parts. That means that most of a star is dark matter. But that raises another question. What happened to all the dark matter in the early universe? Why is it mostly in stars today? Scientists don't know the answer to that question, but they're working on it. In the meantime, we do know what dark matter has to do with the fate of the universe. According to Einstein's theory of general relativity, gravity determines the fate of our universe. If gravity is strong enough, the expansion of the universe will flip and our universe will literally begin to collapse. When that happens, we'll be in for a big crunch. The ultimate heat death of the universe. But if dark energy is growing stronger, that won't happen. Instead, we'll be ripped apart. You see, if the growth of dark energy is faster than the gravitational pull of dark matter, then our universe will expand so quickly that everything will be pulled apart. Galaxies, stars, planets, people, nothing will be safe. It's called the Big Rip. While it might sound a bit dramatic, it's actually a real scientific theory. Someday, it might be proven correct, and that means that someday we could all be ripped apart. But before we get too scared, let's talk about the other possibilities. Part 3, dark energy. If dark energy is growing weaker, our universe will collapse in a big crunch. But if it's constant, our universe will expand forever. Finally, if dark energy is growing stronger, we'll be ripped apart in a big rip. But if dark energy is constant, then we'll expand with the universe, moving away from everything we've ever known. In that case, we'd eventually drift apart from every other galaxy, doomed to wander the cold, dark reaches of space forever. Sounds depressing, right? Well, it's not the end of the story. See? There's also something called the cosmological constant. It's a way of measuring how strong dark energy is. If the cosmological constant is 0, that means dark energy isn't changing at all. Our universe is expanding at a steady rate and will continue to do so forever. But if the cosmological constant is positive, that means dark energy is growing stronger. The expansion of the universe is speeding up and we're hurtling towards the Big Rip. On the other hand, if the cosmological constant is negative, that means dark energy is getting weaker. We'll keep expanding for a little while longer, but eventually our universe will collapse in a big crunch. So what's the value of the cosmological constant? According to scientists, it's between -2 and +1. That means we never experience the heat death of the universe or the Big Rip. Instead, our universe will keep expanding, but at a slower and slower rate. Eventually, it will stop expanding altogether and we'll be left in a state of minimum entropy, aka maximum boringness. Now, here's the thing. We can't prove any of this. It's all just theory. The fact of the matter is, we simply don't know what the future holds. But that doesn't mean we shouldn't try to figure it out. Part 4. The future of reality. If we want to understand the future of our universe, we need to understand the past. Dark matter and dark energy played a critical role in the formation of the first galaxies. But we don't really know what that role was. If we want to know what the future holds, we need to study the origins of our universe. To do that, scientists are building the world's largest and most powerful telescope, the James Webb Space Telescope. When it launches later this year, it will be able to peer back in time to see the first galaxies form after the Big Bang. Those galaxies will help scientists understand what dark matter and dark energy were like in the early universe, which will help them predict how they'll behave in the future. The Webb telescope will also be able to look at exoplanets, aka planets outside of our solar system. Scientists hope that one day it will be able to detect signs of life elsewhere in the universe. Okay? Maybe that's a little bit optimistic, but anything's possible. Ultimately, though, our future remains uncertain. Will dark energy tear us apart, or will it bring us together? Only time will tell. But one thing's for sure. The future of our universe will be shaped by the same forces that brought us into existence. And understanding those forces is up to us. We've come a long way since the days when people believed the Earth was flat. Today, we know that our planet is just one of many orbiting a star. And we've only scratched the surface of what lies beyond our solar system. With new discoveries being made all the time, who knows what wonders await us in the vast expanse of space? But one thing's for sure. The more we learn about the universe, the more we realize how much we don't know. We live in a universe made mostly of shadows. Dark matter binds us. Dark energy drives us apart. The real mystery isn't what we see in the stars, but the invisible forces holding reality together. On screen, subscribe for more cosmic mysteries.